Doesn't matter if you are a founder or if you are working somewhere as an employee, the two most important things that you are being paid for, first is the problem that you are solving, and second is the cost that you are saving. Even if you are founder, then your first important step is to provide the value to the customer, but at the same time do that in a best optimal way. And now that we are using all the advanced tools these days, we are moving from monolithic to microservices, and we are putting everything to Kubernetes, especially the workload that is CPU intensive, memory intensive, that needs super scaling needs in the real time. We are moving to Kubernetes for those, right? But at the same time, we are paying a really huge cost for managing and maintaining your Kubernetes cluster, and that is why we are doing this video, so that we can understand what are the options that we have and what is the best way to optimize your Kubernetes cluster cost, so that you don't end up paying millions of dollars of bill every month, right? So in this video we'll be doing that with a tool called CastAI that has been one of the leaders in the market of cost optimization, and we'll do that with the help of an end-to-end demo. We'll try out many things. There will be a lot of things that I have not even tested it, so I'm going to try it out while recording it. So let's go ahead and let's do the demo. Alright, so this is what we are going to do in this video, in this demo. So first I'll walk you through how it works and how we're going to do the setup. So on the left side is our original state, where we'll set up the EKS cluster, we'll install CastAI agent, and then on the right side is all the changes that CastAI will make to your cluster, and based on different factors such as based on your cost optimization, based on the number of nodes that are running, plus the number of nodes that are required, the number of pods that it needs. It does a lot of calculations in the backend for you, so that you don't have to manually do those things. Now, first let me just walk you through what it is and how does it work. Okay, so over here we have an EKS cluster. So I have used EKS cluster for this demo, which is Elastic Kubernetes Service, a managed Kubernetes service in AWS. But feel free to use any Kubernetes service of your choice. You can go with AKS or EKS or GKE. It's totally your preference. And this particular tool, CastAI, it works well with all the managed cloud providers, right? I've tested this with AKS. I've tested this with EKS. I'm using it with EKS specifically because I had EKS credit. So I don't want to spend a lot of money because I don't have credits in AKS, right? So it will be out of my pocket expenses. So that's why I have used this one, but it works well with all the major cloud providers. So here is our EKS cluster. So we'll start with provisioning an EKS cluster. So when you create a cluster, it comes with default node pool for your control plane. So control plane node pool is not visible over here because it's understood like a Kubernetes cluster is running. So it will have the control plane node pool, or it will have multiple nodes for control plane. So that is there. So this is what we'll provision. Then we'll create another node group for your worker nodes. Now we cannot go with the default node pool that is created for worker nodes because we need to make some modifications. I will walk you through it when we do the changes, but we need to do certain modifications. So we need to create a custom node pool for worker nodes, and we need to have it created, like you can create it after the cluster provisioning or before the cluster provisioning. It just, you need to create the node template as well, right? So node template can be created before cluster provisioning, but node pool will be created after the cluster provisioning. So I'll walk you through all the steps, step by step, so don't worry about it. Now here is our EKS cluster. We created the node pools, we created the node group, and then based on that we have created this node pool. So this node pool, as you can see, will have 4 or 3 whatever on demand nodes. Okay, you can enable cluster autoscaler in that so that it could add or delete nodes as per the requirement. And you have multiple nodes, but they all are of same type because they all are part of same node pool, and I'm using on demand nodes for starting. Now I will also be deploying a sample application. So a URL shortener app, it's basically microservice based app, and I will provide you code and everything in the GitHub repo, and it will have multiple microservices. So if you see this GitHub repo, I'll share the link in the description. So it will have all these manifests. It will have PostgreSQL database. It will have multiple services. It will have front end ingress controllers, Nginx ingress, many other things, right? And storage class as well. So all these things will be deployed so that we can test this CastAI tool on the actual workload and on the actual cluster, right? To mimic the real world production environment. Now it could have multiple other workloads as well. It's up to you if you want to deploy more workload, if you want to do the stress testing, it's up to you. Okay, and then we will install CastAI pod agent. Okay, so I'm sure it will be visible. So there'll be CastAI pod agent which will be running on all the nodes. This pod agent will be connected to the cluster with a read-only access, right? So we'll create the cluster role binding, but that will have the minimum access. So basically list, read, get, watch, only the read-only roles it will have, so that it won't make any changes as of now. So it will make the changes, but it will be at the later stage. To get the metrics, to get the data, metadata from the cluster and from the nodes and from the pods, it just need the read-only access. So that's what we'll start with. Okay, so what it will do, it will get the metrics. As you can see, these are all the nodes, and CastAI pod agent will be running on all the node, and then it will get the metrics from all of the running pods, all of the running workloads plus node as well, and then it will export the metrics to CastAI, right? So a console will be available to you where you can view those metrics, we can visualize those and make meaningful things out of it. Okay, and the way it works is it sends metadata information and cost resource utilization, and it also recommends best node and workload configurations. All these details will be sent to CastAI, right? And then based on that, based on the metadata that it got, based on the metrics and real-time data that it got from the node, from the CastAI pod agent, it will recommend the best node and workload configuration. So that's what it does on the backend for you, and it keeps optimizing the cluster for you, right? It will keep making those changes to you. And then there is a manual option then. So let's say you have just did the setup, you have just installed it, so cluster optimization could take time, but you can manually trigger the balancer. So there is a feature called CastAI Rebalancer. What it does, again, based on the metrics, based on the recommendation and insights that it got, it make the changes to that cluster. So for this feature, we will be adding additional roles, additional cluster binding and RBAC roles, which will have the access to make the changes to the cluster. Okay, so the changes that it made, it's just an example. Earlier there was, you see, earlier there were 4 nodes. Now it had changed it to 3 nodes as per the best practices, and it's just an example, right? It could be earlier there were 10 nodes and now it changed it to 4 nodes. Anything, like whatever it find it as a recommendation and optimization, and whatever could save the cost without compromising the performance, it will make those changes. Okay, and now over here you see all the nodes were on demand nodes, but over here it kept maybe a couple of on demand nodes and a couple of spot nodes, or in this example there are 2 on demand nodes and 1 spot node, right? And the workload also, it rebalanced it. Like earlier there were like through 2 pods in the first node, and over here you see there are 3 pods in the first node, and it does that optimization for you, so you don't have to manually worry about it, and you don't have to manually do that. That's the overview of what we'll be doing in this demo, and like how the CastAI rebalancer works. And now we'll start with the setup. So we can head over to this repository. Okay, and we'll start with the first step, which is create the EKS cluster. Okay, so you can follow this, you can follow the video, whatever you feel you are comfortable with, right? But I would suggest following up the video, because I will also be sharing all the nuances behind it and all the details that I know about it, and that whatever I have tried, right? So yeah, so first step is go to the AWS console and create a cluster with only in the auto mode and with only the system node pool, and enable all the possible add-ons that you want and wait for it to become active. So let's go over here and let's search for EKS. hit on create cluster, and then there are two modes, EKS auto mode or custom configuration. And the way I have tested it, I mean, you can select all the modes, but you can go with the auto mode or custom configuration as well. I'm gonna go with the auto mode for now. So let's call it CastAI cluster, and I'm gonna select the Kubernetes version 1.33, one of the latest versions while I'm recording it. Like use the default options, so let it create IAM role and node IAM role. I'm just gonna use the default subnets, and I need to make some changes to the node pool as well. So let's see where it is. Networking, observability, okay, public endpoint is there. And yeah, it doesn't give me a lot of options, so let's go with the custom mode. Custom mode is good, and inside custom mode you can select the EKS auto mode, so that I have more options to make the changes, right? So let's select with this one, cast AI EKS. Okay, that is good. Upgrade policy is standard. Now create node pool. We only need system node pool. So let's remove the general purpose node pool. We only have one system node pool for control plane nodes. Let it create the IAM role and allow cluster administrator access through EKS API. That is good. Keep all these things as default and hit next. VPC, let's go ahead with the default VPC, 5 subnets, and let it auto create the subnets and everything else. Cluster endpoint, let me see what I've tested with. I believe it was public endpoint that I've used, but you can go with public and private, whatever you feel comfortable with. Okay, and then that's good. Hit next. Now, metrics, maybe just the CloudWatch metrics for now, because I'm not gonna use Prometheus in this demo. Logs are required when we have to do a lot of troubleshooting. So we'll start without the logs, otherwise it will add additional cost to it. So let's keep it disabled. And over here, we can install some add-ons. So let's go ahead with node monitoring agent. We need core DNS and proxy, network metrics exporter, CSI driver, VPC CNI. Okay, let's select, okay, I don't need SageMaker, and then cloud watch metrics, guard duty runtime monitoring, EFS ESI driver, a network flow monitoring agent, no SageMaker, CSI snapshot, no SageMaker, pod identity agent, and no, I don't need this. Okay, and then there are some community add-ons, cube state metrics. I've actually used metrics server, mm, but this is more about generating the Prometheus metrics, so let's remove this. And cert manager, if you want to expose the application on HTTPS port, I'm not going to do that in this demo, so let's just keep it default. Yeah, it should be good. Hit next, and now it will ask if you need any particular version for each of the add-ons. So there are options. You can select the version if you want, or by default it will keep the latest stable version. So I'll just let it do it. Okay, and hit next. Review everything looks good. Hit create. Now there are no node pool that will be created for worker nodes, only a system node pool for control plane nodes will be created, right? So let's go to cluster, and it's creating. It's going to take some time, so let's go ahead and see the next step. Next step is to create a node group with custom launch template. Okay, so let's do one thing. Let's copy the GitHub link, and I'm just gonna do one change. Okay, so let's do the git clone. Okay, I have cloned the repo. Let me open that in the browser as well. Downloads over here. Okay, right. Now, let's open the terminal window as well. All right. So over here, there's a README that I was following. So like this is what I need to do now. I need to first create a launch template, right? I believe I have already logged in. So I'm just gonna go and create a launch template. So this is the option that I've told you is mandatory for CastAI to work. So you need to enable these two metadata option in the launch template, which is HTTP put request hop limit as 2 and HTTP tokens required. Right. So let's just copy this. Yeah, I'm just gonna copy this and execute it over here. Okay, it will ask me for the authentication if I'm not logged in. So let's do AWS configure. Okay, and you need to provide your access key, secret ID, and so on. So let's go back and generate the access keys. So I am over here. Okay, IAM. Let's go to IAM. And users, this is the user I'm using, and let's create a security credential. Access keys, create new access keys for CLI. Okay, and hit next, create access keys. Now I have this access key over here, which I'm gonna paste it, and then secret access key, which is over here. I'm just gonna copy it and paste it over here. Default AWS region is, let's see which region I'm using for the cluster, is US East 1. So US East 1, and just enter. Okay, now I have logged in. Now let's execute the command again to create the launch template. Okay, it says it gave me the output, so it should be created over here. Let's go and check it out. Launch templates. Okay, this is the one, and yeah, it's been created. So I think we are good to create our nodes using that launch template once the cluster is provisioned. So let's see if it is still going on. Yeah, still going on. So let it complete. Let's see the next steps. So we have completed the node group creation. So after creating the launch template, once it is created, you can add that launch template in the node pool configuration in EKS. So I'll just let EKS provisioning to complete, and then we'll do the next steps. So let me just pause the recording for now. All right. So after a few minutes, the cluster is active now. Let's go inside the cluster and go to compute, and over there you will see there is one node which is C6G large in the auto mode, and it's part of the system node pool, and there is one built-in system node pool. There is no node group. That means there is no additional node pool that we have for user nodes, right? So let me just add a node pool over here and give this a name. Let's call it worker. Select the node IAM role. Let's select the node role that we have created. Okay, and let's remove this. Okay, now use the launch template. So we need to use the launch template that we have created earlier. uh, Remember this one over there? Yeah. So I'm just gonna create this node group with this launch template. So let's select this. If you have not created the node template now, you can still create it, and then you can either use this launch wizard to create the node template, and all the options that we have provided, you can provide it from here and add the metadata details as well. It should be over here somewhere inside the advanced details, I believe. I think, yeah, this is it. Metadata request hop limit, and there was one more option. So both the options you can select it from here, create it, and then once you hit refresh, it will be visible in the drop down. Okay, so we have already created it. I'm just gonna select it, hit next. AMI, feel free to use Amazon Linux image, Ubuntu, whatever you feel like, and let's select the demand capacity as on demand. Instance type, let's select a bigger instance. Let me see. Yeah, let's select T3 medium for this. Yeah, T3 medium is there, so that's okay. And node group size, let's go to desired as 4, minimum 2, maximum 10, or let's go ahead with 6. And yeah, let's go ahead. Node group maximum and available is 1. Let's hit next. Let's keep the default subnets. Yeah, and verify everything. Let me see if I am forgetting anything. um Launch template has necessary IAM role, yes, and then select the node group, and yeah, let's hit create now. Okay, now this is also gonna take some time, so it will provision those nodes and then add it back to the cluster as the worker node group. So let's go back over here in the compute, and it's still creating, so I'm just gonna keep a watch on this, and once it is active we can see the next steps. So there are no nodes yet, so let it create, let it complete the provisioning, and then we'll come back. Okay, so as we can see, my nodes are ready. I can see 6 nodes over here. 1 2 3, yeah, it's showing 5, but it is saying 6 because we have the 6th node in the next page. So yeah, six nodes are ready. Let's move ahead for the next step. It says this is done. Now you should have AWS CLI already installed, which I already have because I already ran the AWS configure command. And then you can just CastAI sign up. Before we move forward, I want to give a huge shout out to CastAI for this amazing product and for sponsoring our video. So if you want to try it out, go and check out this link over here, cast.ai/Piyush. The link will be there in the description section as well, so don't worry about it. And let's continue with the video. Alright, so now I'm gonna do the sign up on CastAI. I will share the link in the description. You can sign up free on CastAI and you can follow this step. So if you try to do that with Gmail, you won't be able to do if you don't have a business email. It needs a business email, but you can use this email address and password, right? So let's do that. Okay, it needs uppercase, lowercase, blah blah blah. Okay, let's add that. Okay, now it's asking me to confirm. Let me just do that in a separate window. Okay, so I have verified it. Now let's get started. Let's add the details. Continue. Um okay, let's add engineering DevOps. Let's hit finish. Okay, so now we have logged into our cluster, and when you log in, it will show you a default demo cluster in which you can go and check the details. So it's their cluster, but once you connect your cluster with it, this will be gone. Okay, so that's what we're gonna do. Let's proceed further, and first let's try to access the cluster using this command. So let's go back over here, and I'm gonna add the region, which is US East 1 for me. US East 1. Okay, let's select the cluster name. The cluster that I have created was cast A is in uppercase. Okay. Okay, it said added new context. So if I use kubectl get nodes, I should see the nodes 1, 2, 3, 4, 5, 6, 5 worker nodes over here, and let's add an alias kubectl. So k get pods. There are no resources in the default namespace, but if I do k get pods in all the namespaces, I should see all the add-ons and all the system pods, right? So we have kubeproxy, CSI drivers, port identity agent. There are a lot of pods running. Okay, so this is good. Let's go ahead and let's go over here. So the next step is to install the CastAI connector. So log into the account and then go to your connect option and then select the cluster details from there. Okay, so over here, connect your first cluster. Now there are different options that will be provided to you. Like as I've told you before, it supports wide variety of clusters. So EKS, AKS, GKE, OpenShift on AWS, KOps on AWS, or anywhere cloud on premises as well, right? So what we need to do is, I'm sure this is visible, we need to copy this command. What it will do, it will download the CastAI agent using this token that is generated for you, and it will execute that on your cluster so that your CastAI agent will be installed. Okay, so I've copied the command. Let's go back, clear the screen, and let's paste it over here. Okay, so as I've told you earlier, it creates a lot of resources. So it creates a namespace for CastAI agent, resource quota, port disruption budget, service account, secrets, config map, and cluster role bindings for getting the details, like from getting the metrics, live data from the cluster, RBAC roles, and role binding, and then finally the deployment. So if I check get namespace, there should be a new namespace created, which is CastAI agent, as you can see over here. And if I want to see the resources, get all hyphen namespace CastAI agent. Okay, so these are the resources. There are pods, deployments, replica sets, and config map, and all other things are not namespace scope. That is why it is not visible, but it should be created already. Right, let's go ahead over here and click over here which says I ran the script. So the read only agent has been provisioned. Now this is done, cost monitoring setup is done. Now CastAI will take few minutes and it should be able to monitor the cost of your cluster. Now we need to do the next steps like cluster optimization, workload autoscaler, Kubernetes, and cloud security. All these features will be configured using this script. So just copy this, it will have the API token, it will have the URL, and then the command to execute and run the agent. So let's go back and execute this command as well. It says JQ is not installed. Okay, so let's do brew install. I believe it should be JQ. If you are on Ubuntu, Windows, you can just Google the command to install JQ. It should be fairly simple. Okay, and it should be installed. Yeah, it's done. Now let's run the command again. Oh, YQ is not installed. So brew install YQ. Okay, let's execute it again. Okay, now it's installing the packages and it says installing autoscaler, blah blah, creating new role, creating new instance role. So now it needs a new role so that it could make the changes to your cluster based on the policies that we have assigned it to. So all the policies will be auto created, all the role will be created and attached to the node group as well. So yeah, let it do all those things, and now it has installed CastAI workload autoscaler as well, and it's now testing it. If it is up and running, so it will wait for all the pod replicas to be up and running. So let it do it. Okay, rolled out successful, all the pods replicas are up. Let's see what it's gonna do next. Okay, so looks like everything is installed. Let's see if it has created a new namespace or in the existing namespace. So we have one for CastAI agent. I guess this is the only one. So let's do get all hyphen n CastAI agent. Okay, it created all the rest of the objects as well within the same namespace. So as you can see, it has created a lot of these because it comes with a lot of features. Rebalancer is one of the features that we'll talk about in this video that will do the demo, and there are many other features like there is workload evictor, which will check the workload that needs to be evicted from one node so that the underutilized node will take the optimization into account, right? There are some pods that are still coming up. As you can see, this is pending, but it's fine. It will be up soon. But what we did, we ran this script. So let's hit I ran the script. Okay, now it says all these features are enabled. Now you have this autoscaler settings over here. So we need to enable the scaling policies. So unscheduled poll policy, what it will do, it will automatically adjust the size of Kubernetes cluster so that all pods have a place to run. So it will make the size for the upcoming pods. So you enable it and then it will ask you few customizations. If you want to taint the node, or if you want to, let's say, configuration name, we don't have any configuration yet, but resource offering, specify what resource offering instance you want to schedule for your workload. So let's select on demand as well as spot and spot fallback. That means if it is not available, then temporarily schedule the affected pods on demand nodes, but let it keep the default. And architecture, do we need GPU enable instances? No, not for this demo. GPU sharing, and then enable container live migration. This is another important feature. Maybe we'll talk about it sometime later on. And then apply constraint, enable CPU limit. So you can add your CPU limits over here as well if you want, and hit save changes. Okay, so this is for the unscheduled pod policy, and there is this template. The next one is node deletion policy. This will automatically remove node from your cluster. So this works as a cluster autoscaler. It will delete the node that is not required to save the cost. Okay, and it will adjust the pods running on that node, evict it, and move that to the different node. Okay, so let's select the default option and enable the evictor, which will evict the running pods. CPU limit policy you can enable if you want, and hit save changes. So autoscaler is also enabled. Now let's go back. So we have unscheduled pod policy and not deletion policy. Now CPU limit policy you can also add if you want, but for now let's just keep it default. So before we do anything on the server, before we start with rebalancing and optimization, let's do one more change. Let's add some more nodes to the cluster. So what I have done already, I have added additional nodes to the worker node pool that we have created earlier, and I'm going to create one node pool. So in the compute, you see the desired size of the worker node pool is now 10, and I have created one more node pool. Okay, and the desired size for this one as well is 10. So if you check this node pool, what does it have? It has 10 nodes should be created now. Yeah, it has 10 nodes, 5 here and 5 on the next page. And then the instance type I'm using is C1X large, so that it uses a bigger instance. And I put some load on the server so that it should show some significant amount of the cluster utilization and some significant saving. Okay, so let's go over here and see in the cluster list. You see the total compute cost is this much, and there are 22 total nodes for the server. And let's see if the server is connected. Yeah, it was already connected, just asking me if I want to connect again, but that's okay. Let's go inside the server, and the compute cost, do we see it over here? Not over here. Let's go to the score. So your cluster is underperforming. It shows that, here's the summary: CPU over provisioning under 40%, memory over provisioning under 50%, and few other things, right? It is just showing the recommendations, what you need to improve, like improve CPU, improve memory, and so on. You need to improve the node template CPU utilization as well, and all other things, right? What workload autoscaler is off. So let's go to cost monitoring. Here is our cluster, and here's the spend so far. Now if you go to workloads, it will also show you the cost per workload. You see, we don't have anything like any custom workload provisioned yet on the cluster, but there's a sample project in the GitHub repo, in the same repo, so you can use that. It's a URL shortener microservice application with multiple microservices, so you can also install that and it will show you the workload running as well. Okay, for now let's go further in the available savings section. Okay, so this is important. So currently the current compute cost is $4,200 per month. Okay, that's what it is showing, and you see the optimal setup score is 0.2% over here. Now, the first option is workload right sizing. So it is enabled. Second is use spot instances. That means your workloads will be scheduled on the spot instances, which is cheaper than the on-demand instances. And there is another option, spot friendly. What it will do is, so it will make sure that your critical workloads are running on demand instances and your non-critical workloads are running on spot instances. And you can manage this with the help of taints and tolerations as well. So if you select this one, your cost will increase significantly, maybe not here, because it says 12 workload are not spot friendly. Okay, and if we use all workloads, so all workloads will be running on spot nodes. It will provide you some significant savings. Now, if you want to use Graviton support, it is cheaper than the current optimized x8464 nodes, right? And this is really important, cluster schedule. So if I disable this, it is not currently showing it the exact amount because it takes some time. Okay, so you see the current compute cost is 4199. Okay, with all these nodes, but because I don't have a lot of workload running, that's why it detected it. And see, it says, CastAI says, we only need 3 nodes. We don't need 22 nodes. We only need 3 nodes of these machine family. And your cost will go down from 4,200 to $73. That's a huge saving because we don't need 22 nodes. We only need 3 nodes, maybe bigger instances, but that's what we need as per the workloads that are running on the cluster. And because I have just provisioned the cluster, but if you have cluster running for a long time, it will also take that into account. It will check all the historic data and do the future forecasting based on that, right? So you see it is showing some significant changes over there. Now if you use cluster schedule, this cost will go down to $8.73 per month. Okay, what it is, it has 2 options. One is your cluster average run duration per day. Okay, so it says, let's say I'm gonna use 22 hours per week. I'll be running this cluster 22 hours per week. For example, if this cluster were used for training purpose or just your dev purpose, your testing purpose, and you will only be using couple of hours each day, then you can select any of these options. And there are machine learning algorithms running by CastAI, and what it will do, it will check all the historic data. It will check for next few days at what time you run the cluster mostly, and based on that it will optimize your workload autoscaler, right? It will check, okay, maybe from night after 5 p.m. your cluster doesn't run, so it will scale down the node to 0. And when you usually start your cluster, when you start working on your cluster in the morning, it will automatically scale up your cluster. So it will take care of that all by itself. Okay, so that's the cost comparison, and that's how it will look like. And let's see what else. Okay, so let's go to rebalancer. Let's prepare a new plan. Okay, now it will show you if you do the rebalancing now. So rebalancing is basically what we discussed over here. It's a service that is running on CastAI. What it will do, it will check everything based on the workload and best node configuration. It will realign your cluster. It will change the nodes. It will change the node count. It will change the machine type family, and it will change the way the pods are being scheduled on the cluster, right? So it will do all those changes, but before making the changes, it will show you how it will look like. Okay, so for now I have 22 nodes selected, and if I click on generate plan, It will take maybe a minute or a few seconds to generate the plan, right? So now after waiting for almost 15-20 minutes, but I would recommend wait for at least 30 minutes before after you configure the CastAI agents and everything. So now as you can see, it says the cluster cost is 4100, which will be 1700 after the rebalancer executes, and the compute cost is 2500, which will be $118 after the rebalancing. So you see there is a saving of 95%. That's huge. That's a huge saving. And it will, earlier there were these many nodes. So you see we had 10 nodes of each size, but because optimizations run automatically in the cluster even without the rebalancing, so it already reduced the size to 6 nodes, 7 nodes, 4 nodes, and so on, right? So there are still 10 nodes for this, but there are only 7 nodes for T3 medium, which was 10 the minimum sizes, right? Or I might, oh no, I changed the minimum size to a lower number so that it could go down, right? But anyways, it did that optimization even though there were 2500 was the cluster amount and was the compute cost. Now after this, it will have one M5A large, one 6A large, one C1A large, and one 6C large. So these are all the instances that will be provisioning after this. So 4 to 6 or to 8 instances instead of 19. So from 19 it goes down to 8 instances. And 15 is the current node count because it already reduced from 19 to 15. Now from 15 to 8 it will go down after this rebalancing, and also it will change the instance family to accommodate the working workloads, right? So let's hit on rebalance, and after this we'll see the huge difference, and that we're gonna come back to this after 5 minutes. So I'm just gonna pause the recording. Okay, it's still in progress, but I wanted to just do a quick recap of what we have done so far. Otherwise, it will be so easy to get lost in the conversation. So what we did, we spun up a EKS cluster, right? We created a node template with some additional metadata options, right? Using that node template, we have created a worker node pool. Now, with this cluster, like when it was spinning up, we only had system node pool. So only system node pool. So you can call it node pool, node group. It's one and the same thing because in GKE it's been called node pool, and in EKS it's called node group. So it's one and the same thing, right? So you can call it node group, node pool, doesn't matter. Now we created a worker node pool. Now this is minimum 10 nodes, desired 10 nodes, and maximum 15 nodes. Okay, and we use the same configuration when we added another node pool. So created second worker node group as well with the same node count and node configuration, etc. Now what else we did? After the nodes were provisioned, we installed CastAI. We actually did the sign up to CastAI, and then we installed CastAI agent on the cluster. And then we checked everything. We checked all the cost optimizations, and we went to available savings, and then we did rebalance. Okay, so these were all the steps that we have taken so far. So once you go there, it says rebalancing complete. Now you see your monthly cost has reduced to $118, and the node count changed from 19 nodes to 8 nodes. So that's a huge saving. That's a huge saving that it did for us. Otherwise, there was a lot of cost, right? So if you go back over here now, the cluster is optimized. It has 4 nodes, 4 on-demand nodes. I don't know why I did not selected the spot nodes, but that's okay. Maybe 2 nodes for the control plane as well, right? So that's okay. And if we check the score, it's still not updated, so that's all right. So many of these options take some time to be updated. For example, this total compute cost, it will take some time to be updated. See, it's still showing the same cost that it was showing earlier, so it will take some time, but it will be updated soon, right? This has updated total nodes, And over here, the price is not updated yet. Compute cost is still showing as $2,000, but it will be done soon. And yeah, that's it. That's it for this demo. I hope you were able to test it out by yourself. If not, you can follow along the video and understand how does it work in real time, how you can save more than 90% of savings by just following this simple tool. Okay. So yeah, that's it from this video. Make sure you clean up your cluster, otherwise you will end up in a lot of cost. And the way cleanup works with EKS, you first have to delete the node groups and then you delete the cluster. So do that in the same order and you should be good. So yeah, thank you so much for watching. I hope you have a good day.